Hello viewers, I'm here at Queen's Strawberry Farm of Alfonso Cavite to do my vlog. This is Dr. Teresita Felicelda Gonzalez, proprietor of Philippine Global Light Skill Review and Tutorial for Online Services. Before I would like to proceed to the topic I'm going to vlog today, I'd like to start this by reiterating my slogan. The best investment in life is education. The topic that I will tackle is about computation of samples for research. What really is a sample? A sample is a subset of people or a total population that should be selected out of a bigger group of people that will serve as respondents for your research. Sometimes we call these samples in some other researches as research respondents, sometimes research subjects, and most often also is referred to as research participants. Why is there a need of sampling in selecting the subjects? It is because the researcher could also save time, money, and effort in the research because it would be very hard to spend much money in the distribution of the survey questionnaire to the respondents selected. So that is why we should simplify or reduce the total population into a lesser number, because spending so much money out of survey is not also good. Anyway, there is also a method in selecting samples so that you could get a total number, a number of respondents, in which the respondents as if are able to attend to the answering of the data. What is the main purpose of survey research? Why is it that a researcher will really conduct survey? Most often, the commonly used research is the quantitative and the qualitative method. A survey research is to describe the characteristics of a particular population. This is usually accomplished by collecting data from a certain sample. Therefore, the first step is what we call a sampling, that is to define the needed population. Usually in thesis, this is part or chapter 3, research methodology. In the research method, data collection is very important because we cannot interpret results without this. We cannot also analyze. There should be analysis after reaching up to the results of statistical computation. So again, what is total population? Say for example, your research is about the evaluation of the implementation of modular distance learning during the pandemic. Naturally, your respondents would be number 1, students, number 2, teachers, and sometimes parents are also utilized as respondents. So this total population of the teachers, the students, and the parents would serve as the group consisting of all people to whom the researchers wish to apply a finding. So in order to be able to reach two results, the researcher needs parameters, the target population, and the accessible population. So what are these parameters? The parameters are the data that is collected by the researcher so that this will be taken from a total population in order to reach on a particular research question stated in the statement of the problem. These are what we call as descriptive data. Example, the respondent will reach up to 300. Capital N is equal to 300. Capital N refers to the selected respondents. So that is why the data collected out of the demographic profile, say like gender, age, the highest educational qualification, and etc. These are what we call as parameters. Next, what do we mean by a target population? A target population is also what we call as the sample that is being taken from a very big population in such a manner that we would be reducing the number of respondents. That is, as what I have said, to save time, money, and effort of the research work. Number 3, accessible population. Usually the target population is not, or it could not be reached. It is impossible that 100% of the target population would be there. So the accessible population is what we call as those number of respondents that is accessible, meaning to say they are there immediately in one-time survey. So if 1, 2, 3, even up to 5 is lacking, it is okay. It will never reduce the actual result of the total research. It's because you're going to reduce also the number, and might be 295 only is because 5 are absent. So in this case, licensed statistician will compute using a degree of error because not everybody was there. Now, let's go back to sample. What truly is the meaning of a sample? It is a subset of people used in conducting studies. They are used to represent the population from which they were drawn. The kind of sample that we get during the survey of a research work will also depend on the type of population that you use. Say for example, you have research subject using soaps. What is the commonly used soap in taking a bath? If you select, so draw questions asking the respondents as to what is the most common soap they are using. So this is not anymore respondent or a participant, because usually respondent and participants refer to people. So we call the soap as a research. It is a sample that is referred to as research subject already. It is already a subject, not anymore a respondent or a participant. What is the difference between a parameter and a statistics? Parameters are data collected from the respondents referring to demographic profiles, say like asking for the highest educational qualification of a particular teacher, asking as to how many seminar trainings they have for the past years in teaching, or asking for their age, their gender. These are what we call as parameters. What about statistics? What is really statistics all about? They are the data that is being collected from the samples, again, from the selected respondents, which refers to what we call as the inferential statistics data, because we are already making inferences about the population with data collected from the sample. If we talk about inferential data, as say for example, we hear somebody or a baby crying on the other house, as your neighbor. Once the baby cries, you will have guess inferences. So like saying this one, the baby is crying because uh, she or he is hungry, or it might be that it, he is bitten by an animal, or it's possible also that the mother or the father is beating the child. So these are inferences. This is what we call as intelligent guess. So out of these inferences, there are statistical formulas used so that we'll be able to reach up to the proper data or the result, and then after that, getting the value, we try to interpret the result. It might be using z-test, it might be t-test, it might be correlation, or a person or moment correlation of formula. What are the most common method of selecting samples? In selecting samples, it is also possible that we take all the population. Let's say for example, your study will involve organic farming, and there are only few farmers using organic method. So that is why if in a particular division or a region or a place, there are only 45 to 50 farmers applying organic farming. So you could take them all, or take the whole universe, take them all, because there are only few. So that is taking all the population. Another second method of sampling is random sampling. Each subject of the population has an equal chance of being selected. So let's say in a classroom of 50 students, let's say in your action research, you need at least half of them. Out of 40 students, say for example, you would like to get 50% a sample. So you take only 20 out of the 40. So what would happen? You can use the class record and then get the all even numbers. So the name of the pupils listed under even numbers, get it. So you take the half of 40. So take only 20 out of them. That is random sampling. So another is stratified sampling. In stratified sampling, so by the word itself, stratification, to stratify is to group respondents. Say for example, you want to collect the number of voters to vote for a particular candidate during this coming election in May. So what will you do? You stratify. So how do we stratify? We group into subgroups. So in a total population of a particular town, get 5 or 10 in the marketplace. Get another 10, 5 to 10 in the business sector, the bigger businessmen. Get people in the school. Get some in the community, and then get some also in the church. Get some from other subgroups. So trying to collect them all. If you get 10 in every group, if there are 10 groups or 10 subgroups in a general number of population. So you'll be able to get at least the sum up of as to who will possibly win during the election period. So that is what we call as stratified sampling. Next is the two-stage cluster random sampling. So first we have to take all. Number 2, we have the random sampling. Again, number 3 is stratified random sampling, the one that I have explained a while ago. Number 4 method of sampling is what we call as two-stage cluster random sampling, wherein samples are chosen from pre-existing groups. So that is why it is called a two-stage cluster random sampling. In the previous research, they had been used already. They have already used the sample, and then in the recent research, you need the same group of respondents. So you are going to take the same number of respondents, same way or same selection in the previous year. So that is what we call a two-stage cluster random sampling. Number 5 method is systematic sampling. So how do we use systematic sampling? It is by selection of every nth subject in the population. Systematic means there is a system in trying to select the samples or the respondents of your research. So say for example, you will have drawing of lots. Write all the names in a piece of paper, roll them out, then place them in a bowl, and then drop all the names in there. You pick one by one. So out of 200 names in the bowl, you get at least half of it. So you get 100 only. So it is random, still random. You are not selecting because you did not see the names. So you are just picking the rows of the name, and then upon getting or after getting 100 selections, these 100 names will serve as your final respondents. This is what we call a systematic sampling. There is a system, but not really selecting because you know this person, you know that student. No, just select it or pick it up in the bowl of the selected names. Number 6, convenience sampling. So convenient, if you are in a convenience store, so it's easy for you to pick anything you like, say like 7-Eleven, no? So the same thing in sampling conveniently. So subjects are easily accessible. You just serve the survey questionnaire immediately when the people or some of respondents are accessible. Who are there anyway, they serve as your respondent immediately. So that is what we call as accessible sampling. The last is purposive sampling. So when it's purposive sampling, subjects are selected according to purpose. Say for example, if you want to conduct research work regarding readers, to select the very good readers, independent readers. Who are these pupils who are considered as struggling readers? They cannot read. They can only identify the letters, so but not able to read the words. This is what we call as purposive sampling. Subjects are selected according to group. You group, there are how many pupils who are struggling readers, and then who are those who are already independent readers. So you will have to count by trying to assess the pupils by giving them reading instruments. So you will be able to identify who are those who doesn't know how to read. yet. So there are 7 types of sampling. First is again, it's taking all the population. Number 2, random sampling. Number 3 is stratified sampling. Number 4 is 2-stage cluster random sampling. Number 5 is systematic sampling. Number 6 is convenient sampling. And number 7 is purposive sampling. So there are 7. Now I'd like to continue by introducing the most commonly used sampling formula. If we say most commonly used, so out of 100 thesis, dissertation, action research, or basic research, these 2 are usually used. So you should learn this one because this is very important. The first formula is determination and selection of interval to systematic sample. Second is computing for the sample by using Sloven's formula. So the first one, let's go back. First is what we call a systematic sampling. The formula is K, letter K, which resembles the sample, is equal to population size divided by the sample size. Say for example, there are 100 fraternity members. This is the population size. And then you want to get only 25. And the sample size, there are 25 fraternity members. So if you divide 100 by 25 equals 4. So 4 is the selection interval. Meaning from 100, you will have an interval of 4. 1, you get 1. 2, 3, 4. Then get 5, 6, 7, 8. So interval of 4 will be applied. So until you get 25 out of these 100 fraternity members. This is what we call a systematic sample in computing. This is the easiest way to select sample. The second one is what we call a sample for Sloven's formula. Sloven's formula is this one. Small letter n is equal to capital letter N divided by 1 plus capital N times e raised to the second power. So what is the meaning of this formula? Small letter n means the sample. Then capital N is where you get the total population. Divided by 1. 1 there is a constant number. So if it is constant, that will not change. No, it is always 1. 1 plus capital N, again the total population, multiplied by the E. E is the degree of error, then square it. So say for example, there are 225 students, so plenty, no? There's many. And you like as a total population of grade 10 students as your respondents to be selected. So the source of your sample. So what will you do? N equals capital N, which is 225. Divided by 1 plus 225 again, which is the capital N, multiplied by 0.05 as your degree of error, then square it. So by using calculator, although I'm not using calculator anymore because this is already memorized. And therefore is equal to 225 divided by 1 plus 225 times. You square 0.05, the product is 0.0025. Then proceed. N is equal to 225 divided by 1 plus multiply 225 by 0.0025. So, and therefore is equal to 225 over 1 plus 0.5625. Where did we get point 5625? It is taken from 225 multiplied by 0.0025. So finally, n, small letter n, is equal to 225 divided by 1.5625 because we add 1. We add 1 plus the product of 225 multiplied by 0.0025. So therefore, our divisor is already 1.5625. So divided 225 by 1.5625. The small n therefore is equal to 144. And this is your final sample size. So, see, from a general or total population of 225, you only have 144 as sample taken from or using the formula called Slovens. So, I think that is all for this day. Thank you for viewing and listening to my vlog. Please don't forget to push the button subscribe and subscribe, and then you may also do comments, write comments or reactions. It's okay, it's okay for me, it's normal that you react. And then that is all for today. Thank you again. God bless us all, and please keep safe, all of you.